data loaders. It could be
Sorry, Vinay.
That's fine. It could be an ETL tool, or it could be a workflow or an orchestration tool as well. We'll discuss more about this as we go along. So what we do is, we have these ETL tools, we bring it into a data lake. We, organize the data in the data lake based on, generally we ingest it on a daily basis, or there could be data streaming in as well. So every single day or every single hour, we organize the data by timestamp. And, we also perform some sort of cataloging where we have data coming in and it could be gigabytes or terabytes of data. We need to ensure that we can identify what the data is. So we catalog it, and we also perform something called as data discovery, where which is mostly used by analysts or business analysts in the company. They might be working on one data set, but they might not know what else is available in the data lake. So that's where data discovery tool will come in handy. And data lineage basically is a way to track how your data changes when you ingest the data from a data source, when you bring the data from the data source, and then eventually when you transform it and combine it with multiple data sets, you can actually track the data from the beginning to the transformed or the final version of how it shows up to a business user. So those are the services that support the all the data that we accumulate and the data that we transform. So once we have the data in the data lake, what we do is bring it into data warehouse, which is where we do a whole lot of transformations. So ideally, when we bring it into the data warehouse, we try and perform multiple operations, which is, data quality checks. We ensure that there is no duplication, get rid of all the redundancy, clean up the data as well. So all of that happens in the data warehouse layer, and ensure that when we do all of these operations, the final data that's available for consumption is in the right format. So that's when we call it as trusted data, right? And business can start using that trusted data and start building some analytics out of it. They can start building some reports, some visualizations from it. And then eventually there will be analysts and scientists coming in who will work on the later stages where they can build some sort of machine learning models or AI models and make make some insights or inferences out of the data. So this is how a typical data platform looks like. It's actually more complicated. There's a lot more things going on, but this is a very simplistic representation of the data platform itself. Moving on, just a little bit to add on to the previous diagram, previous slide. So this one's about a hierarchy of needs, in terms of data. So so for a typical organization, they operate at different levels in terms of this hierarchy of needs. For an organization like Wisr, we didn't have a data platform a year and a half ago. So we started building the data platform from the bottom of the foundation, which is the collect layer, and then we moved up to move and store, and then explore, aggregate, and we are actually working on aggregate and label and trying to build or learn and optimize as well. So for a typical organization, they move up this particular pyramid and try and make more and more sense out of the data. So typically for data engineers, they operate in the bottom two layers in this particular pyramid. And sometimes they also operate in the explore and transform, as well as aggregating and labeling the data as well. So as you can see, when you're collecting the data, it's more about logging. There's instrumentation. You're looking at what data you have and how to collect the data into a single data repository, which could be the data lake or the data warehouse. And then you move and store the data. They could be, all of that could be done using ETLs. There could be some infrastructure that needs to be built in, some specific data pipelines that need to be built in. You need to have specific handling for unstructured data as well. Yeah, so all of that happens in those two layers. The next one is about exploring and transforming the data itself, which I spoke about, where you have data quality checks, ensure that there is no duplicate data, no redundancy. The data is all clean for consumption. So that's what we're doing. And yeah, and then basically preparing it for the next layer, any analysts or any data scientists to come in and start, looking at the data, the patterns that can emerge out of those data sets. And basically coming up with some metrics. A business might have various metrics that they might be tracking on. For example, a company that has a customer service, they might have turnaround times on customer complaints as one of the metrics. So we might be tracking a metric to ensure that we resolve customer tickets as soon as possible, and we can use this metric to see a trend of how we are performing as a business. And there might be various aggregated data, which is basically, you have you might be tracking how much business we have done, how much revenue we are earning, how much profit we made. So those could be aggregated data, could also be metrics as well. And yeah, and then essentially you also help the next level, which is to build some machine learning models or AI sort of models that will help automate all of these analytics metrics. They can actually look at the data that is being generated and make inferences and also make predictions for the future. So when we have machine learning models and AI models built in, they can help us extrapolate our existing data and try and try and predict what could happen if we modified a particular metric a little bit. If we changed a particular feature in a product, for example, how would that affect the future of the product? Something like that could we could probably predict based on these models. So as a data engineer, we generally operate at the bottom two layers, but there's also scope of operating at the third and the fourth layer as well. Yeah.
Perfect. Vinay, I've got a couple of questions and perhaps also some clarifications for the broader audience. So, for instance, when you're talking about collecting, right? So, yeah. Can you map that with the previous image, for instance? Where would that happen?
Collecting would happen here in this area from the sources to the data loaders. So basically, it'll be in this area. So before it goes into the data loaders, actually.
Perfect. And what's common question is, what's the difference between a data lake and a data warehouse?
Okay, so data lake is basically consider it as a directory in your computer, right? Or a folder in your computer where you keep everything in that particular directory, but it's not really for an automated machine, it's not making sense on if an ETL tool has to use that data. It's not organized. It's not in a particular structure. So a data lake can be used as a raw storage where data is stored in its rawest format. You can just extract the data from a database, store it as JSON, as XML or CSV. So it's all file storage basically. But when we bring it into a data warehouse, that's where data gets converted into a tabular form, which is more easier to consume for everybody. And you can actually write SQL queries and whatnot. And, it's easily digestible for a business analyst who might not know how to, query the data from a file storage, for example. So the reason why we have data lake is to collect everything, but data warehouse will have only about 20% of the data that is in the data lake. So we don't bring everything into the data warehouse. We only bring it in when it is required for analytics or for
Why? Why do you do that? What are the reasons for not just taking everything that exists in the data lake and just putting it into the data warehouse?
So there could be data that we might not immediately need, but we might want to collect them just for future, right? At this point of time, as a business, we might be working towards solving a particular problem. So that's why we just make those data available. And when we grow as a company and when we start looking at more data sets, we can easily ingest all the data that we've collected from before. So yeah, that's sort of an idea.
I guess there is a bit of a processing and cost implications as well, right? Like if you put everything as it comes into a data warehouse, like your processes get a little bit more computationally expensive and also like proper expensive, money expensive.
Yeah.
So yeah. So we've got a question from Jeronimo on the chat, and he's asking if the data loaders are high maintenance.
It depends on which one you go with. So a lot of cloud providers today, they have, it's all in the cloud. So there's not a lot of maintenance, but there will be obviously some, changes that you might have to do once in a while based on how the data is changing in the source as well. So, but again, so the tool that we are using is an open source tool called Apache Airflow. Which we'll discuss in the next slide. So that is an open source. We host it ourselves and we maintain it, we manage it. Again, the only time you will have to maintain it is when, after the initial setup, you will need to maintain it when you upgrade the product, for example, and when you have to add additional functionalities to it. For example, in Apache Airflow, we can use Python packages to do various things. The basic installation doesn't come with all the Python packages. So as and when we add new Python packages, we'll have to do a whole lot of testing so it doesn't break our existing pipelines. And yeah, so those are the bits that will need some maintenance. So depending on the tool, there will be maintenance and there won't be much. So yeah.
Perfect. And Vinay, on this diagram, right? Like where does the role of a data engineer end?
So it ends at the service data. Anything before, so anything in blue here, or yeah. So all of that is data engineer's role. I mean, a responsibility. Anything in green is basically analyst or a data scientist who'll be working on those.
So essentially, as a data engineer, what you're doing is you're capturing all this data from different sources, you're storing them, and then you're also processing them and maybe presenting them in a unified format. So an analyst that knows a bit of SQL can come in and query just very standardized data, and in that way they can then connect it into some data visualization tool like Tableau or whatever it is, and then they'll get some reports and all of this because I think sometimes people with a lot of experience kind of take it for granted. But the purpose of all of this is that you want to provide the company with information to make better decisions, right?
Yeah, exactly.
Perfect.
And to add on to that, I think a data engineer is also responsible to build data models, which again we'll talk a little bit in the future. So that requires a lot of SQL knowledge as well. Essentially, modeling is about presenting the data or combining multiple data sets and presenting it to the business in a way that they can actually make sense out of the data or multiple data sets working together, I guess. So say, for example, we have a database that is the backend to one of our operational database, but there could be another a SaaS application, for example, a CRM tool or an ERP that has some financial information. So we can combine both of those data sets and build some sort of a model. There could be a business process already that will already be looked at in the organization. So we convert all of that into SQL and process the data every day, so the data is available for business to access. So something like that, building data models is where is another responsibility of a data engineer as well.
Perfect. Thank you for that. Yeah, you can carry on.
All right. So moving on to the next one. So basically, getting started from a programming perspective, the preferred languages in the data or in the industry today is to use Python or Java for most programming or engineering tasks. I prefer Python. I don't know much of Java, to be honest, so I prefer Python. And yeah, it's a really nice language, and it also helps when you have to understand what an analyst or a data scientist in the company is doing, because they usually use Python as well. So you can do a whole lot of things using Python and the data tools and transformations as well. There's various packages available. So yeah, Python and SQL, as I said, when we bring the data into something like a data warehouse, there's a lot of transformations happening, which will eventually turn into data models that business users will use. So SQL is quite important. So that's another language that I would highly recommend. And obviously knowledge of Linux, generally Bash. We might be working with a lot of Linux-based operating system, and Bash is quite handy when you have to build a cron job, for example, or run some quick tasks, for example. So these are what are preferred in the industry. Just a little bit of an example project that if you guys are interested in, you can take up is, you can start by creating a basic Flask API. Flask is again a package in Python, which helps you spin up a web server, for example, and then you can actually connect it to a Postgres database. And then additionally, if you want to continue on, you can build a front end and try and interact, post messages, create posts, and have it persist in the Postgres database and whatnot. So this could be one of the example projects that you can start with.
Is there any reason why you're recommending Postgres?
I think it's because it's very simple to set up, and it's one of the widely used relational databases out there. Yeah, because the other databases, SQL Server are licensed, and there's MySQL as well. Yeah, I think MySQL also would be something that you could use if you prefer that.
Cool.
But yeah.
Cool. Thank you.
All right, moving on. And then getting started on the database or the data warehouse, those concepts. So there's something called relational and NoSQL databases, which is non-relational databases. Relational databases are basically anything that you might know of entity relationship models, ER models, where each table is in some way related to another table, and there's some relationship in it. So that's what is a relational database. And most operational databases in a business will be relational databases. So it's very important from a data engineer's perspective to understand how relational databases work, how we can extract data out of those databases more efficiently in an optimized manner, and try and make and try and bring it into the data lake, for example. And in a similar way, the NoSQL database as well, where there's no relationship between tables or endpoints. So the data itself is unstructured. There could be key value pairs. It could be a JSON, blob within those tables. So how to handle those data sets, that's another challenge that you might have to deal with. So knowing these differences will help make it easy for you. And also on relational databases, there's something called asset properties, which is atomicity, consistency, isolation, and durability. These are the concepts that are very important in terms of relational databases. Based on these concepts, you will have to design your ETLs in a way that you don't, you capture the right data. And because all the data in a relational database is transactional, each transaction is only valid when it completes. So if you learn about asset properties, that talks about all these transactions, how how a life cycle of a transaction starts and ends. And yeah, knowing about those will help you optimize your data pipelines. And there's something called OLTP and OLAP. So online transaction processing and online analytical processing. So these are two concepts, again, from emerging out of these different types of data types that we have, or databases we have. So OLTP is basically how to process data that is transactional in nature. So transactional database in the company, we have data coming in all the time, 24/7. How would you handle that data, and how to store that data, how to use that data? So all of that, all of those questions can be answered when you know more about OLTP and OLAP. OLAP is basically analytical processing, where you are mostly looking at the data, aggregating the data, combining them to build, come up with some metrics, and that's what happens in a data warehouse. Yeah, OLTP is more writing and reading data. All of them happens very frequently. But in an OLAP sort of a database, it's only a lot of selects, a lot of reading, and a lot of aggregating that happens. A lot of calculations happen in OLAP. So yeah, those differences are very important as well. And coming to dimensional modeling or data modeling, as I spoke earlier, it's all about combining multiple data sets from different parts of the business and trying to build a data model that is solving a business problem. So that's essentially what we're doing. And an example project for this is, again, you can scrap some data from a website, pull the data into an SFTP directory as CSV files, or Parquet or Avro, or anything that you're comfortable with. and then build a data or dimensional model in a database. It could be even, you can build it in a PostgreSQL as well. And then load the data into the data warehouse and try to process that as a data model. So you can probably start here for dimensional modeling. Any questions so far?
I do have a question. So for instance, when you talk about data or dimensional modeling, right? Like if I scrape a website, say, I don't know, an e-commerce, right? Like what kind of dimensional model would I be building out of the data that I scrape from there?
I think I would build something like a product model. So what we could do is from an e-commerce website, pull all the information about the products that are available on different days, right? Every day we could have different quantities, different products available on the website. So we could look at building a model where one product was available on a day, and on another day the product is out of stock, for example. And we could look at how to based on that data model, we could understand perspectives in terms of what product is the highest selling in the market. For example, if it runs out of stock, you can try and make inferences on all of that sort of sales metrics, basically. So that's something that we could try and build, I guess.
Perfect. Thank you, Vinay. Do you have a recommendation on when to use relational versus NoSQL databases?
I guess for most operational, if it's a backend for a front end of the business, then I think relational would be the best option to go with. And of course, there's some scenarios where having NoSQL databases makes sense, because we might be collecting documents and some stuff as part of operational work. So that's something that needs to be stored in a NoSQL, because you can't really store documents in a transactional database. So there's obviously some use cases for NoSQL, but mostly from what I've seen, relational databases work the best from a transactional perspective.
Perfect. Thank you so much.
Okay. Moving on, just a little bit about the data processing itself. So we have something called ETLs or ELTs. So these are extract, transform, and load, or extract, load, and transform. So there are two different ways of doing ETLs or ELT, which is this. So why do we choose ETL or why do we choose ELT is basically, when we have smaller data sets, when we are only capturing small data sets every time, it could be a CSV file, we might be extracting a CSV file into a SFTP location, and we just want to bring it into a data lake or data warehouse, when we actually bring it into the data warehouse, we have to transform it on the fly, because it's small data set. It doesn't really need to, we don't really need to load it somewhere and then transform it later on. We can actually transform it on the fly and make it available. But for most use cases today, in most of the data platform architectures that we see today, everybody is using, or 90% of organizations are using ELT, where the first thing that we do is extract and load it into a data lake, and then bring it into data warehouse where transformation happens. And that's where we combine one data set to another, and we try to build data models using those transformations. So there's both of these available depending on how your organization data sources or whatever processes that they might have. You can decide on one or the other. And there's also, there's something called batch and stream processing, where we might, as a business, we might have a need to report or build some analytics in real time, or we might be having APIs as well, or some data that we are generating all the time. So we might want to bring it into the data warehouse and make it available, for analytics as soon as possible. So that's where you would implement something called a stream processing. You can think of Apache Kafka, which is quite a popular tool to do stream processing. Yeah, so it's basically, real-time processing. So that's what it means. For batch processing, you basically run a particular data pipeline on a schedule once a day, typically, or you could run twice or thrice a day as well. So depending on business needs, but it doesn't come into the data warehouse in real time. It is only brought in as a batch. So yeah, those are the decisions you will need to make as a data engineer. So depending on the business needs, you might have to decide which one to go with. There's also, data structure itself that you need to be aware of. There could be structured data, which is a tabular format. If you're ingesting from a database, a Postgres or a MySQL or any of these operational databases, it already has some structure to it. And all you're doing is just bringing the data as is into the data warehouse or the data lake as a file. But when you have to handle unstructured data, which could be JSON or XML, when we bring it into the data warehouse, you need to flatten it out. You need to extract the key value pairs from within those JSON. So that's an additional bit of work that you will need to work with. So that brings some complexity to your data pipelines. Some tools that you can think of using is Fivetran, Stitch, Pentaho, and Apache Airflow, which is what we use, which is also an open source tool. The other three are proprietary, and they are some of them are quite expensive as well. As an example project, I would suggest Apache Airflow have an amazing Docker file or Docker container or an image that's available. So you can simply download the Docker image and spin it up and use something like a Postgres as a backend for Apache Airflow to keep track of data pipelines, for example. And then you could probably build some data pipelines to process the SFTP files that you ingested in the previous slide, in the previous project that I spoke about. And load it into a data model in the data warehouse as well. So yeah, this is something that could be done quite easily because Apache Airflow is available, and there's a lot of trainings and videos available to learn on the tool as well.
Vinay, one question. On the, when you were talking about ELT, you were saying you would extract it, you would load it into the data lake, right? And then you would do some transformation and that ends up in the data warehouse. So the data lake could be any cloud storage, right? It could be like S3 or, Azure storage or whatever it is. What about the data warehouse? Like how do I install a data warehouse and start loading data into it? Obviously, we use Snowflake, but what is something that is freely available to the rest of the people?
So the relational database itself, right? So any database, like for example, Postgres, we can actually build a data warehouse in Postgres. All we need to do is not establish relationship between two tables. Then it becomes an analytical, but it's not very efficient because the reason why we have these analytical database is because they store data on a column basis. So each when we talk about relational databases, each row is stored alongside or each values or each attributes in a row is stored next to each other in memory. But when you talk about analytical database, each column is or the values in each column is stored next to each other. So there's a difference in the way the data is stored for each of these different databases. So there's one of them is row wise, other one is column wise. So because if you think about it, when you're building a data warehouse, you're mostly doing calculations or aggregations on columns, right? And it makes sense to just keep values of one column next to each other because it is easier to get all of the data together and process the data. But if you have one record stored in one page in memory and another record stored in another page, you need to pick only one value from one page, another value from another page. So it has multiple reads happening on the disk, and you have to have more memory to get all of the data in, crunch that data, and calculate or build some sort of aggregates out of the data. So it's more about the internals of how the memory and storage, everything works, right? So that's why one system is better than another. So yeah, again, to your question, how we can build a data warehouse. It's basically building a database without any relationship. And if you're just building a small data warehouse, we can just build it in a Postgres database itself. Yeah.
Perfect. No, that's great. That's great. And yeah, I think it at least gives a basis of how can you do it. And when, if we're doing it locally and we just want to try it out, we also don't even need, we can treat our own disk as the data lake, right?
Yeah.
We just say, files will be there. And then if at some point you want to move them to the cloud, then the processing will be the same. Just depends where are they stored. So
yeah, you can actually use a SQLite database as well if you're comfortable with that. Yeah.
Yeah. Perfect. All right. Thank you.
All right. So this is the last slide that I had. Basically, some of the concepts that I recommend learning when you are starting out as a data engineer. Using Git version control is quite important. The reason being, we as a data engineer, I build a lot of code, and I want the ability to go back and look at various versions, and also keep track of what we're building, and and if we have to reproduce some work, it will be easier if we are building everything as code. And obviously Git gives us the ability to go back in time and look at various versions. And yeah, so I think it's amazing, and helps us keep work, or maintain all of our work in a single place, I guess. And unit testing and integration testing is quite important as well. When we start building data pipelines, we build a lot of classes, a lot of functions. And when we introduce new features, there's definitely a possibility of things breaking, which is where unit testing or integration testing comes in handy. At the moment, we have completely automated it through a CI/CD pipeline, where we can actually for each commit that we do to Git, it actually does unit testing on the fly and tells us whether it breaks some functionality within our data pipeline or classes or functions there. I would also recommend learning networking concepts, mainly because we will have multiple systems working together, and we want to secure the platform itself. We don't want anybody intruding into or messing up the data, or obviously there's a lot of hacking attempts happening these days. So that's one of the reasons we want to secure our platform. So it's important to know those concepts. Learn about one of the cloud platforms, because a lot of AWS, GCP, Azure, all of them have their own offerings in terms of data engineering tools. They have ETLs, they have data warehouses, they have streaming platforms, and yeah, so all of that is available within their platform offering. So definitely a good idea to learn one of those cloud platforms. Docker and Kubernetes, I found most data engineering tools or data science tools are available in the form of Docker images. So highly recommended to learn Docker. And Kubernetes, basically orchestrating all the Docker containers. It's one of the niche skills to have in the industry today. So and when your platform grows bigger and more complex, it helps to learn Kubernetes and manage all those Docker containers. Identity and access management, again, we want to work using the principle of least privileges, where we only grant access or permission to someone who's authorized to perform certain activities, and we need to we need to be able to audit who has what sort of permission on your data platform. So there's also a lot of sensitive data that we might be handling. So yeah, only the authorized personnel should be able to access those data. So that's why this is very important. And also there's something called distributed computing that is very important to learn. So essentially it helps distribute your data across multiple compute nodes when you are processing huge amount of data. There could be terabytes of data that an organization may be looking at on a daily basis, which is where something like Hadoop or MapReduce will come into place. And yeah, you can take advantage of these to process that sort of a data set. So yeah, that's all I had, and I've put in some references which I'll ask Fab to share with you guys as well. Any questions?
Thank you, Vinay. Thank you. That was amazing. And yeah, thank you so much for all the knowledge sharing. I do have some questions that people have been sending on the chat on Slack. I'll translate them for you, and then I'll translate them for them. Okay.
Sure.
Cool. So I guess the first bit, you did cover the data engineering versus data scientist, but there's also a role. You can read sometimes big data engineer, right? So what, is there a difference between them, or is it just another name for data engineer? What is it?
It's I think it's an extension to data engineer role. So it's basically handling large amount of data, right? So there might be companies who might be processing terabytes of data on a day-to-day basis. That's where, when I was talking about Hadoop and distributed computing, the big data skill set is about handling those sort of data sets. And there could be multiple types of data as well. When you're streaming in terabytes of data, and then you have to process it on the fly, there will be multiple systems that you need to cater to. Things like Spark, Hadoop, all of those skill sets. So that's just a little bit of an extension to data engineering.
All good. I'll see how I do it with the translation. So Sebas, you were asking this, vos estabas preguntando esto. La diferencia con un Big Data Engineer es que Big Data es una extensión de Data Engineer y es esencialmente cuando estás trabajando con mucha cantidad de datos, por ejemplo, muchos terabytes por día, y entonces ahí empezás a usar algunas de las herramientas que Vinay estaba contando antes, como por ejemplo MapReduce o Hadoop, que te permiten hacer muchas de estas cosas en paralelo. o también cuando estás trabajando con por ahí data streaming, que nada, por ahí tenés millones de eventos que tenés que consumir y procesar, entonces tenés como una parte de data engineering que está dedicada especialmente a manejar todo lo que es big data. ¿Sí? Cool. Thank you for that, Vinay. There was another question about, do you need to know a lot of math to work on this?
Not on data engineering concepts, but when you go towards data science, that's where a lot of math and statistics come into picture.
Cool.
Yeah.
So, yeah, la pregunta era si hay que saber mucha matemática para trabajar de esto, y lo que Vinay nos cuenta es que para ser un data engineer no, porque en realidad, nada, es más que nada como si fuesen, o sea, sí hay que saber mucho de base de datos, pero quizás no tanto de números, pero ya cuando uno se pasa a la parte de data science, cuando se pasa a la parte de data science, hay que ya conocer bastante más de conceptos matemáticos y mucho de estadística, así que nada, ahí sí hace falta una base fuerte de matemática, pero no para data engineering. Cool. Thank you for that, Vinay. There's another one which is, what are, I get a job as a junior data engineer. What do I do on my day-to-day basis? What does my role look like?
I would imagine a lot of their time will be spent on learning. So they'll be looking at, what is already built in the company as part of the data platform. So they'll be trying to get on board and learn about the data pipelines that they have, the architecture that we've built, different processes on how data gets transformed. So I would imagine 50% of their time is basically on learning. And then I think to start off with, they will be given probably, smaller data pipelines to be built. They could they could do some sort of data modeling as well, or they could just try and fix some issues that a data pipeline might have. That way they can try and learn what's happening on the platform.
Perfect. I'll translate that. La pregunta era, bueno, como un junior data engineer, ¿no? ¿Qué es lo que hacemos nosotros? O sea, ¿qué haría un junior data engineer apenas empieza a trabajar en una empresa, ¿no? Y lo que Vinay contaba era que por lo general él estuvo hablando de todo lo que era data pipelines, ¿no? Que son como estos procesos que nosotros tenemos para extraer la información, transformarla y cargarla en algún lado, o cargarla en algún lado y después transformarla. Y entonces lo que dice Vinay es que el 50% de tu tiempo va a ser aprender bien cómo está hecha esa estructura y la arquitectura de lo que está puesto en la empresa. Y después, para empezar, lo que te dan son pequeñas tareas, ¿no? Por ejemplo, crear un data pipeline vos, pero chico, no súper complejo, o arreglar algún data pipeline que tiene alguna deficiencia, por ahí hay algún cálculo que está mal, o no sé, algo que por ahí está roto. Y si no, bueno, trabajar también en lo que son modelos de datos. Y bueno, nada, eso. Pero el 50% del tiempo, que me parece que es el dato importante, se espera que uno esté aprendiendo, ¿sí? Cool. Vinay, there's a question in the chat about what technology do you use for testing if you're using PyTest?
What technology?
So which unit testing framework are you using? PyTest, or what are you using?
Yeah, we're using PyTest. So we found, so there's unit test and there's PyTest. So unit test is already built into Apache Airflow that we use, or I think it's already part of the Python framework. But PyTest we found is better. It also has all the capabilities of unit testing or the unit test framework also. But it does a little bit more than what unit test can do. So PyTest is what we use. Yeah.
Cool. Thank you for that. La pregunta era si él en particular usa PyTest para testear. Lo que decía Vinay es que Apache Airflow ya viene como con su framework para hacer unit test, pero que PyTest es más completo. Así que sí, lo que él recomienda usar, o por lo menos lo que él usa, es PyTest. Awesome. I actually had a question on the, when you talk about unit tests and integration tests, right? So I think I wanted to be super clear on this. So essentially, these pipelines, these data pipelines that you are creating, they're essentially Python programs, right?
Yeah.
And those Python programs, they can run, they can be orchestrated by something like Airflow, right? And that's what you can write unit tests for.
Yes.
Okay, perfect.
You can also write unit test for data as well. So that's where I think I didn't speak about DBT here, which is the transformation tool. But that's, you can use a tool like that where to test whether a particular data model has values in a particular range. For example, if you want to ensure a column has yes or no only, and it doesn't, true or false only, for example, and it shouldn't have anything else, then you can make sure that you have those tests in place to validate those. So
perfect.
I think you could call them data validation checks instead of
data validation checks. Okay, cool. I'll translate that. Mi pregunta era, en realidad la explicación que estaba haciendo al principio, la aclaración que estaba haciendo al principio es que cuando uno habla de data pipelines, lo que estamos hablando son programas de Python, ¿no? O scripts de Python que corren y son orquestados por Airflow, por ejemplo. Entonces, un data pipeline por ahí pasa por varios de estos programitas de Python, entonces ahí es donde nosotros podemos escribir unit test e integration test para esos programas, ¿no? Para asegurarnos que están haciendo lo que nosotros queremos. Y después la aclaración que me hace Vinay es que hay algo que se llama DBT, DB larga T, que esencialmente lo que hace es transformaciones con SQL, ¿no? O sea, vos puedes seleccionar un data source y transformarlo con DBT y poner esos datos transformados o agregados en otra tabla, por ejemplo. Y lo que él contaba es que ahí se pueden hacer como si fueran unit tests, que en realidad son data checks o chequeos de datos, donde, por ejemplo, te termina fijando, bueno, en esta columna, si es, por ejemplo, no sé, cuánto salió un producto, y bueno, fíjate que no haya, por ejemplo, números negativos. O si esta columna debería ser solo valores de sí o no, entonces fíjate que no haya ningún valor por fuera de eso. ¿Sí? Entonces todos esos son chequeos de datos que también se pueden hacer con una herramienta que se llama DBT. All right. Awesome. Thank you for that. There's another one. Yeah, this one is a bit personal. So what was your favorite data engineering project and why?
I think when I started Wisr, I got the opportunity to build the data platform from scratch. I had never had this opportunity before. I think building this whole platform from scratch, building Airflow as our orchestration platform, or the data ETL tool platform, and the data warehouse itself, the data lake, all of this coming together was quite fun, I guess. So this would be my favorite project so far, and it's going on.
Awesome. Thank you for that. La pregunta era, bueno, ¿cuál era el proyecto de data engineering que más le gustó a Vinay y por qué? Y Vinay cuenta que, bueno, que cuando llegó a Wisr ya hace 1 año y medio, él tuvo que crear todo esto de cero. Y entonces, bueno, obviamente tener la posibilidad de aplicar todas las buenas prácticas que aprendiste en otro lado para crear algo de la forma que a vos te gusta es interesante. Así que, bueno, nada, Vinay ha estado haciendo eso con su equipo de Data Engineering el último año y medio y, bueno, todavía sigue en curso, pero ya está dando sus resultados positivos. Awesome. And then last question that I have is, do you need, like, is it mandatory to get a degree, to a uni degree to work on this, or can I learn it by myself and still work on the field?
Yeah, I mean, I know a lot of people who have who've been self-learners, and they've become good data engineers. So I think it's all about learning and upskilling yourself, I guess. It doesn't really require a uni degree for that matter.
Perfect. Lo que le pregunto a Vinay era si hace falta un título universitario para hacer un Data Engineering, y lo que dice Vinay es que él conoce muchos ingenieros de datos que aprendieron por su cuenta, son autodidactas, así que nada, 100% se puede, obviamente hay que aprender bien las bases, pero sí se puede y no hace falta un título. All right, cool. I think that was the last question. Oh yeah, no, there's one more. Did you ever use a delete without a where?
I'm sorry?
Did you ever use delete without a where clause?
I have.
We all have, Jerónimo, we all have. I once dropped a 40 million row database in production. That's quite fun.
But fortunately, because when you run delete, the transaction is logged in the database, so you can always go back and restore before the transaction. So you can actually try and revert the transaction as well.
I wish I knew that when I dropped the 40 million table, but
that's something a database administrator would know.
Awesome. All right, good stuff.
Right.
I think that's pretty much it. But yeah, thank you so much for taking the time to share this with us. We'll upload it to YouTube a little bit later. But yeah, thank you so much. It was amazing. I learned a lot as well. So yeah, perfect. Thank you so much, Vinay.
Well, thanks for the opportunity as well. It was great speaking. Thank you.
Awesome. All right.
Have a good one.
Thank you guys. Take care.
Bye.
Bye.
Thank you. Bye.